Welcome back, geometry class. My name is Miss Graham, and I'm going to be taking you through lesson 6-2, looking at two-column geometry proofs. You should have up pages 66 through 70 out for this lesson. We're going to start off looking at our learning targets for today. Today, we're going to complete two-column proofs to prove theorems about segments. We're also going to complete two-column proofs to prove theorems about angles. Now, earlier, we wrote two-column proofs to solve algebraic equations. You justified each statement in these proofs by using an algebraic property. Now what we're going to do is we're going to use two-column proofs to prove geometric properties. You must justify each statement by using a definition, a postulate, a property, or a previously proven theorem. Now recall that vertical angles are opposite angles formed by a pair of intersecting lines. As in our figure below, we can see angles 1 and 2 are vertical angles. The following example is going to illustrate how to prove that vertical angles are congruent. Now, if we look over to the left side, we know it says the vertical angles theorem says that vertical angles are congruent, but we're going to go through how we know this theorem from a proof. So below, we can see example A. The theorem is vertical angles are congruent. Our given information is that angle 1 and angle 2 are vertical angles, and we are going to go through a series of statements and reasons to prove that angle 1 is congruent to angle 2. So our proof starts off with saying the measure of angle 1 plus the measure of angle 3 is 180 degrees. We know that because it creates that straight line right there. That is our definition of supplementary angles. Now, our next statement is that the measure of angle 2 plus the measure of angle 3 is 180 degrees. Again, we know that by the same reason, definition of supplementary angles. That's the definition of it. Remember, when you add two angles right next to each other and equals 180, they are both supplementary to each other. All right, for our third statement, we can see that the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. What we did here was we used the substitution property. So they basically said, okay, I see that there's a 180 here, there's a 180 here. Since this equals 180, I can substitute it right up there, which is exactly what we get right here. The next step is the measure of angle 1 is equal to the measure of angle 2. Interesting. All right, so remember, how did we able to jump from this step, from the previous one above? Well, think about it. What is the thing that's missing? The measure of angle 3 on both sides. What we did was we subtracted the measure of angle 3 from both sides. That's the subtraction property of equality. Now, our last step is taking the measure of angle 1 and changing it to be angle 1, right? If the measure of angle 1 is equal to the measure of angle 2, then we must know that angle 1 is congruent to angle 2. That goes back to definition of congruent angles. If we know angle measures are equal, then we know the two angles are also congruent. All right, we walked through our first geometric proof. We're going to go through another one together. So let's go ahead and look below. So here it wants us to supply the statements and reasons that are missing. Our theorem that we're going to prove is that all right angles are congruent. It has a given statement of angle A and angle B are right angles. And we want to prove that angle A is congruent to angle B. A lot of times when we are going through geometric proofs, what they give us initially, that given piece of information, is usually our first statement in proofs, or one of the first few statements. So we have angle A and angle B are right angles. So I'm going to fill that in here. Angle A and angle B are right, and I'll abbreviate angles. And like I said, that's our given piece of information. So that's our reason filling it in. It's our given. Okay, what are we looking at next? So they gave us the statement. It says the measure of angle A is 90 degrees. And it says the measure of angle B is 90 degrees as well. So think about how we went from statement 1 to statement 2. Really, we know the definition of right angles is that an angle measures 90 degrees. So that fits our definition of right angles. So that is our second step. Let's go ahead and look at our third one. Whoa, okay, this says both blank. Okay, well, maybe what we could start thinking about is that ending statement, right? We want to definitely end on the idea that we want to prove. So think about how we want to prove angle A is congruent to angle B. So I know that's going to be my final step down here, but I'm not necessarily sure what the other blanks are. So I kind of got to figure out, kind of got to work backwards a little bit and think, okay, how do I go from step 3 to step 4? What can I do to figure that out? How can I show that both angles are congruent to each other? Well, think back to the problem that we worked at above. If we were able to show that their angle measures were equal, then we were able to show that the angles were congruent. So thinking back to what we have above, oh, well, what if I did a little bit of substitution? What if I substituted, instead of writing 90 degrees, what if I put in the measure of angle B was 90 degrees, so the measure of angle A is equal to the measure of angle B. So that's our substitution property. But something else I'm also going to say, something else that is very possible in this case is our transitive property. That might be a property that we probably forgot about way, way, way long ago. But our transitive property says, okay, if we have, let's say, if we have the statement A is equal to B, and then B is equal to C, therefore we can take out this part right here and kind of go to each of the steps. We know A is equal to B, B is equal to C, so therefore we know A is equal to C. We can kind of take out that middleman. So this could also be our transitive property. This isn't always the case where you can do substitution or the transitive property, but just kind of keep that in mind. If you're more comfortable with substitution, then definitely use that. All right, let's go ahead and finish up our step 4. We can see that we have that measure of angle, sorry, we don't have the measure of angle A, it's just angle A is congruent to angle B. So that is our definition of congruent angles. Let me grab my pencil, a highlighter. A lot of times people might say definition of congruence. I like to be a little bit more specific here because we are looking at angles. Let's go ahead and head to our next page, page 67. I'm going to give you an opportunity to look at the try these A through B section. I want you to try looking at the proof for A. So we can see in our given information, Q is the midpoint of line segment PR. It also gives us, it gives us another piece of information. It says segment QR is congruent to RS. Our goal is to prove that segment PQ is congruent to RS. So I want you to go ahead, take a look at this problem. It already lists the statements for you. I want you to go ahead and see if you can come up with the reasons. Maybe some of the things we've seen already today, maybe some of them from our previous lesson. See if you can fill in the reasons right now. Go ahead and pause right here. All right, let's go ahead and resume from here. If you looked at the math tip in the right column, you saw that more than one statement in a 2-column proof can be given. So looking at our pieces of information, we do see this. We see Q is the midpoint of segment PR. That is our given piece of information. So I'm going to fill in the first reason as our given. We also see another important part of information here as well. We see that segment QR is congruent to RS. That is also a piece of given information, so I am also going to fill that in as given. Sometimes we like to put all of our givens at the beginning. Sometimes they can be distributed throughout. You're going to see that as we approach different proofs. Now we have to start connecting some of the pieces together. So I want to figure out, how do I go from my first statement to my second statement? Q is the midpoint of segment PR. And we were able to come up with PQ, that segment, is congruent to QR. Well, that goes back to definition of your midpoint, right? If we have a point that's in the middle, that shows that our two segments on each side are congruent to each other. So we're going to fill in definition of midpoint right here. Perfect. Now, we already did step 3, but let's just think about what we're doing. So sometimes it's nice to label it in the picture as well. If you're looking at your picture and you see, hey, PQ is congruent to QR, sometimes I like to label that with tick marks. All right, the other piece of given information is that QR is congruent to RS. So we know that these two segments are also congruent. Oh, okay. This is making a lot more sense now. Look at this. We then have our final statement. They gave us segment PQ is congruent to RS. Well, think about this. This is kind of like our last problem when we said A is equal to B, B is equal to C. So therefore, we know A is equal to C. That's the transitive property that we're working with. So this is our transitive property, right? All right here. So looking good. Nice. That's our final step. Cool. Hopefully you were able to get something similar to this. And if not, it's good that we talked about this and you're able to correct your mistakes. We're going to go ahead and try part B below together because we can see it gives us all the reasons and we have to fill in the statements. Let's read our problem. It says we're going to complete the proof. So our given piece of information is that angle 1 and angle 2 are supplementary. It also gives us another piece of given information. Measure of angle 1 is 68 degrees. Now, this always isn't the case, but for me, I like to work with that first piece of given information and see what I need to work with. So I'm going to go ahead and fill that in for my statement here, saying angle 1 and angle 2 are supplementary. All right. Now, I have to look at what my reason is next to see what I'm going to actually be filling in for that next statement. So the reason that they give us is definition of supplementary angles. Think back to what we've done previously, such as maybe our first example, example A on page 66. We saw that when we were given the measure of two angles adding to 180 degrees, that was the definition of supplementary angles. So if we know angle 1 and angle 2 are supplementary, that means the measure, let's try it again. That means the measure of angle 1 plus the measure of angle 2 equals 180 degrees. So nice job. We're referring back to the problem we did before. Now we're going to go ahead and look at number 3. Well, it gives us a little bit of a hint. We have our other piece of given information. So lo and behold, we're going to put in the measure of angle 1 equals 68 right there. That was our measure from up here. Okay, and we want to go ahead and look at how do we get to step 4. It says we're going to use the substitution property. Okay, substitution property. So think about maybe what you have, not just from the step before, but maybe both of these steps, steps 2 and 3. How can we get there? What can we do to substitute? Oh, couldn't I substitute the measure of angle 1 as 68 degrees back up there? Yeah, I could totally do that. That is actually what we're going to do here. So instead of writing the measure of angle 1, I'm going to put 68 degrees plus the measure of angle 2 equals 180 degrees. Nice. All right, and then it tells us on number 5, we're going to use our subtraction property of equality. That's kind of already a nice hint for us of what we're actually going to do. We can see that we probably would subtract 68 on both sides. Now, when we're doing a geometric proof, we don't always show this work. We can actually state it, but we're saying we're doing the subtraction property of equality. So we want to see what we have left after we subtract 68 from both sides. So 180 minus 68, we're going to get the measure of angle 2 as 112 degrees. And if you look up above, that was what we were trying to prove. The measure of angle 2 equals 112 degrees. Sometimes you could put that prove statement at the bottom and then kind of work your way through it. I wanted to show you a couple of ways how maybe we don't have the statements, maybe we don't have the reasons, maybe we don't have a mix of both, because in the future, you are not going to be given any of this. All you're going to be given is our given information and what we need to prove. But don't worry, we're going to work our way up to that. Let's go ahead and flip to the next page, 68. Now, this example would work really well if we had some cutouts, if we were able to do this a little bit in person, but I'm going to have you work on this one on your own time. What I'm going to tell you is what you're going to be asked to do in this example. So in this example, it actually gives you all of the statements and all of the reasons. So what it's asking you to do is to take all of the statements, which we have over here. So these are our statements. And then over here, it has all of the reasons. And we're going to be working with this proof where it says angle A and angle B are each complementary to angle C. And our goal is to prove that angle A is congruent to angle B. So these are not put in the correct order at all. They're actually scrambled up, they're mixed up. So your goal is to make sure, okay, I can figure out how to put the statements in 1, 2, 3, 4, 5 step order, and I can put the reasons in 1, 2, 3, 4, 5 step order. Something I also noticed about this is that there is a little math error. If you look at the reasons section where it says the third one down, definition of congruent segments, it should be definition of congruent angles. Now, if you're a little bit confused by this and you just kind of want to see the proof and see how it's analyzed, it's actually right below. This answer key is actually right below. So this is really our answer key. That shows us, okay, how we were able to unscramble all 5 of the statements and all 5 of the reasons to match them with each other. So go ahead and take a look right now at this. If you want to try putting them in your own order and, you know, cover up the answer key, not look at it, hide it, and then check your answers, you can. Or if you want to go ahead and look at the answer key and kind of analytically think about how they put together the statements and reasons for this proof. Once you've had time to do this, we're going to go ahead and head to page 69. Let's go ahead and look at the try these C. So for the try these C section, you have 2 problems where just like on the previous page, you had to rearrange all the statements and the reasons to match with each other. You're going to do this in part A. It doesn't give you the answer. I will give it to you in the next few minutes, but I want you to go ahead, maybe in the margin of your page, go ahead and make a 2-column T-chart where you have your statements and you have your reasons. Make sure you number it on out. You're only going to have 4 steps, but you're going to go ahead and try to figure out how you can write our given information of angle 1 and angle 2 as vertical angles, and the given information of angle 1 is congruent to angle 3, and see if you can figure out how to prove that angle 2 is congruent to angle 3. So I'm going to have you work on that problem in the margin right now. Go ahead and pause the video. Let's go ahead and check out a sample proof of A in the margin on the right. It started off with our given information of angle 1 and angle 2 are vertical angles. Then our next statement was angle 1 is congruent to angle 2, and that reason was that vertical angles are congruent. That might be a new piece of information for you, but remember, they gave this information to you right there. All right, let's look at what we did next. It went to step 3, so angle 1 is congruent to angle 3. That was our given piece of information. And then step 4 was what we wanted to prove. Angle 2 is congruent to angle 3. It was through the transitive property, saying that angle 1 is congruent to angle 2, and then working our way downward. All right. We're now going to go ahead and try to write one on our own. That's right. A little bit scary, but that's okay. Let's go ahead and look at part B. I want you to write a 2-column proof of the following theorem. So remember, the theorem gives us a basic understanding of what we're going to work with. So our theorem is if 2 angles are supplementary to the same angle, then the 2 angles are congruent. Our given pieces of information are that angle R and angle S are supplementary, each supplementary to angle T, and we want to prove that angle R is congruent to angle S. I'm going to start helping you figure out how we can work through this problem. And then I'm going to give you an opportunity to go ahead and finish it. To help you out on this one, I started to set up the 2-column proof of statements and reasons. I'm going to help you out in telling you that there's going to be 5 steps here, but I want you to go ahead and see if you can fill in what the first statement and reason would be. Hopefully you know our reason is always going to be given for that first step, most likely. And that the statement that we're working with is that angle R and angle S are supplementary to angle T. So I'm going to go ahead and show you that. If you weren't able to get that down, go ahead and pause the video right here so you are able to do that. Now, let's figure out how we can go to step 2. think about what our ultimate goal is. Our ultimate goal is to get down and prove that angle R is congruent to angle S. So maybe what we could do is we could fill that in down at the bottom. Angle R is congruent to angle S. Now this is the tricky part because this is what you have to think out in your head. How do you go from one step to the other? How are we able to do this? Let's look back at step one. We're talking about two angles, each being supplementary to angle T. So maybe we could think back to that definition of supplementary angles. Maybe that's where we can say, oh, the measure of angle R plus the measure of angle T is 180 degrees. Now, maybe we don't just have to have that piece of information. Think about what other angle, when added to T, will give you 180. That'll also be angle S. So we actually have two pieces of information that we could put here. So the measure of angle R plus the measure of angle T is equal to 180. Measure of angle S plus the measure of angle T is equal to 180. And that goes to definition of supplementary angles. Now, how do we get to step 3? Think about what's our ultimate goal. We want to show that angle R is congruent to angle S. I know the textbook says something a little bit different than I would use, but with me looking at this, I know the measure of angle R plus the measure of angle T, it equals the same thing as the measure of angle S plus the measure of angle T. So for me, I would probably do a little bit of substitution right there. Now the textbook says we can use the transitive property. Okay, that's fine if you want to do that, but I think for me, what I'm going to stick with is substitution. So I'm going to write down substitution. Oop, sorry, that was the wrong pen. Let me try this again. Substitution. So that's my preference here. All right. Okay, let's see if you can fill in the last two steps. Go ahead and pause the video right here and see if you can do that. All right, let's see if you're able to do that. The next step that I wrote down here is the measure of angle R is equal to the measure of angle S. Think about what we did. Oh, we subtracted. Yeah, we subtracted out that measure of angle T on both sides. Nice job. All right, and then last but not least, think about this, right? This is the definition of congruent angles, right? If the measure of each angle is equal to each other, then the angles have to be congruent. Hey, give yourself a pat on the back. Nice job for finishing this first proof, which was really on our own. You can go ahead and pause the video right here because your teacher is going to give you what tonight's homework is going to be. For Miss Graham's class, I want you to go ahead and turn to the next page, turn to page 70. For Miss Graham's class, your homework for tonight is going to be on page 70. It's going to be number 4. What you are going to be doing is you are going to be filling in the steps of the blank statements and reasons for this proof. Remember, we have the given and proven information right up above. All right, good luck and have fun.